So I hope you can see this. So we'll be talking about some AI programs. So now that what type of AI programs, or we'll be calling these AI programs as agents. Okay, so when I'll be using this word agent or AI program interchangeably. So agents is primarily a term that is used for representing AI programs, right? Okay, so here are some questions. The first question is that if you want to write an AI program, which we are calling an agent here, what would be the design of that? And that's a very important question. So what would be a design of that? The second question with that, okay, if you have got the design, then what would be the function? Okay, what would be that agent? How will you write that program for an agent function, right? And what are those challenges? Then what are the challenges? So and these challenges would primarily be different from application to application. So let me just show you a small video, and maybe from there you will be in a position to see that, okay, what are those challenges? Can you see this? I hope it works well on this. So can you okay, so it's getting a little slow. So can you see this video? Okay, wonderful. So let me just play this. So because of the okay, so it might be a little slow, but I'll also I mean, I will give you the link of this also on the Moodle, and you can also play it on your own. But so you all know what this is. So what is this system? Right. So yeah, so let me just share this. Okay. So what is this system? This is a vacuum cleaner, right? I hope you are able to see the system clearly. If you are asked to design this system, okay, if you are asked to design this system, what would be the first thing? For example, let's talk about the learning component and the reasoning component in this particular application. Okay. So what do you think would be the learning component in this system, and what would be the reasoning component in this system? What will you call learning and what we'll call reasoning. You have seen the application of this vacuum cleaner, right? So what do you think? Okay, what else? We have got an answer which says that sensors is learning. Sensors, so let's just stick to this. Sensors. Sensors are basically learning, or sensors are providing the data for learning. So what do you think? Okay, Sanat, you're right. Sensors are data of learning, right? So sensors will provide you the data for learning, right? Uh, what would the actuators do? The actuators will the actuators will primarily, once you have got the data from the sensors, it will go to your algorithm, your program, your agent, whatever you call it. That agent will actually suggest some actions. Say, for example, here the cleaning is an action, and those actions will then be executed by the actuators. So actuators are primarily, yeah. So actuators are primarily those parts of your machine or of your agent who are performing the actions. Okay, and sensors are primarily getting the data, and then you have something in between which we call as an agent, which takes the information from the sensors, runs some algorithm on it, suggests some output, and then that output is executed by the actuators, right? And that's what is happening in case of this vacuum cleaner. That in case of this vacuum cleaner, uh, the vacuum cleaner is primarily uh, is doing exactly the same thing. Okay, it's taking the data through sensors, running through its algorithm, gives you an output, and then you actually perform that actual, right? The actuators, exactly. Okay, so what are those? What would this agent or what would this AI program consist of? This AI program would consist of, which is generating this vacuum cleaner, would consist of sensors, installation of sensors, acquisition mechanism, data acquisition, getting data from the sensors. If you require some sort of cleaning of that data because sensors might have some noise in it, they may be doing some malfunctioning, then you clean that data. You take that data, put it in an algorithm. The algorithm would then suggest that, okay, perform this action, clean, or move to some other place, right? And then basically the actuators will perform that action. If the suggestion is clean, the actuators will clean it. If the action, if it is, yeah, noise from the signals and the environment, exactly. So that's because what is happening here. So what would be the reasoning in case of vacuum cleaning? The reasoning in case of vacuum cleaning would be that, okay, let me just take you to this diagram on this slide. So vacuum cleaner agent. So what would be the reasoning? The reasoning would be that whether I should clean this room or not, if I consider myself to be a vacuum cleaner. So the reasoning would be that, okay, am I present in room A or room B? Suppose these are two rooms, and this robot is capable of moving from one room to another room, right? And is also capable of cleaning this. So what would be the learning part? The learning part would primarily be, okay, the learning part would be that, okay, how to clean. Am I in room A? Right? And the reasoning part would be, have I completely cleaned the room? Should I move to the next room or not? Okay. So what would happen if I've completed cleaning both the rooms? Where should I go and where should I rest? Right? Now, this is all related to reasoning and learning. What would be learning? Whether the room is dirty or not. So you'll apply some sensors. The sensors will sense the floor and they'll see that, okay, the room is dirty. That's the recognition problem, the learning problem. Right? Again, the room has been completely cleaned. You'll have to find out that. Okay, you have to recognize it, whether it's clean or whether it has been cleaned or not. That's the recognition part. Okay. And the reasoning part would be that, okay, should I start from A or should I start from B, or should I, let's say, uh, be resting? So these are all different types of decisions that have to be reached. Right? I hope this is clear. Okay. So here on this particular slide, on this particular slide, on the bottom, you actually see two things here which are written here. One is called the precepts and the other one is called the action. Right? So precepts and actions. So these are the two things that I would be explaining in the next couple of minutes. I hope before I explain this particular thing, precepts and actions, is this concept of the difference between learning and reasoning clear? Okay, is it clear to everyone? Okay, that's nice. So okay, so let's just see that what would be the perception would mean. So perception primarily means that how do you actually uh, yes, so this is just one mask. This is just one of one example that you have just given. Okay, so but it's there could be other examples. Okay, so learning relates to identifying whether the room is clean or not, and reasoning would primarily be the justification for taking a certain action. So what is the justification? If you ask the robot that why did you go to room B, the robot may answer saying that, okay, because the room A was clean and I thought that room B may not be that clean, so that's why I moved to the other room. Okay, so that sort of a reasoning comes from the robot. So the reason of taking a particular action. So this is again another way of looking at this. I hope this clarifies, Mask. Right. So there might be a small disruption because I'm switching to another different network. So if I'm off for a few seconds, just bear with me. Okay. So we are here. So now let's talk about the last thing that we need to discuss, precepts and actions. So actions are really very clear. So for example, you have a situation which is shown here. You have got two rooms. The robot is in room A, it's dirty. Room B is also dirty. So the actions are that the robot could move from A to B, and the robot could move back to B to A. Okay, the robot could suck the dirt, and the robot may not perform any action, no operation. So NOP primarily means no operations. So moving left, moving right, sucking the dust, and moving from or just resting. So that would primarily be the different types of actions that might be taken. Okay, so let's move on to this percept part. So percept part is primarily is the information that is perceived through sensors. Okay, so what happens is that, okay, the sensor information that you get, that sensor information has to be processed, right? And as a result of that process, you reach a certain conclusion. And that conclusion that you reach is what is called a percept. Okay, so I'll give you an example here. So the robot is present in room A in this case. Okay. So robot, let's say it asks a question to itself saying that, am I present in room A? So how will the robot answer that question? We'll look around. So suppose a camera is fixed here. The robot would look around, and let's say A is the dining room and B is, let's say, the bedroom. So the robot would look around and try to see that, okay, is there a bed in the room? Okay. Or is there a dining table in the room? So based upon that, it will try to identify a dining table or a bed. And once that's being identified, then it will reach a conclusion that, okay, I am present in the dining room. Okay. So that conversion is called perceiving the information, or processing the information, or refining the information in order to reach a certain conclusion. Okay, for example, if you get some sort of a signal, a sensor captures some sort of signal, right? And how would you understand that that signal is coming, that signal that you are receiving through that sensor, is that signal coming for a dining table or for a bed? How would you distinguish between the two? Or in other words, suppose you have an obstacle somewhere, and the sensor, you get a sensor value from that obstacle. How would you find out whether there is a obstacle or not based upon the sensor reading? It's not straightforward, right? It cannot be actually identified straight away. So what will be done? You'll have to carry out some sort of data processing there, right? That might be signal processing, that might be some other way of data processing, through which you will try to identify, through which you will try to understand that what is the signal that you are getting. Okay. And based on that, you reach a conclusion. Say, for example, if the robot is present in room A and it's getting some signals, the robot will try to identify that, okay, is this signal telling me that the room is dirty? Or is this signal telling me that the room is not dirty or is clean? Okay, that can be done through some sort of processing. We call it data processing, pre-processing of the data, whatever you call it, right? And that is what we call as the processed data, not the raw data that is coming from the sensor. That processed information that is coming from the sensor, which is turned into an information, is what we call as perception, right? Humans actually do that. If you see something far away, you may say that, okay, in my opinion, this is, let's say, a tree. The other person could say that, no, this is not a tree. It seems something different to me. It's not a tree. Now, these are the different perceptions that a person is actually taking, right? Is this clear? So perception is the processing of the raw data that you get. Okay. And once you perceive that information, then a certain action is recommended, not before perceiving. If you want to turn away from an obstacle, you first need to identify the obstacle. You first need to find out whether the signal that you are getting is from an obstacle or not. And so this is what you call as perception. So what we'll actually be doing is, or what this vacuum cleaner is actually doing is that it gets the sensor information. From there, some perception is built. Then that goes into your agent function, which recommends some action. And then that action is taken through the actuators. All clear? Any questions on this? So I hope it's clear to everyone else also. So if there is anything that that requires, that's nice, that's wonderful. So here is how you can write down your agent function for a vacuum cleaner. So I've taken this very simple example of a vacuum cleaner. Here are the perceived sequences. Okay, so the robot, so the first perceived sequence is that the robot is present in room A and the room A is clean. That could be one perception that might be taken, that might take place. Okay, so if, for example, the robot perceives that that it's present in room A and the room is clean, let's say, okay, this is the perception, then what should be the action taken? The action taken is move to the other room, move to right. That's the action that has to be taken, right? And if the perception is that the robot is in A and the room is dirty, that means that A is dirty, then the action to be taken is suck the dirt. Okay, that's the action that should be taken. So these are all different precept sequences, right? You might have, and then on the right side of this column, you will find all these sequences that you have got, like the possible actions that you might have, right? So these are the different, and how can you actually implement a very simple vacuum agent can be developed based upon this precept sequence. And it's a very simple rule that you have implemented. This is just a very simple sort of an AI implementation. This function is doing what? This function is saying that, okay, give me, so what is agent saying? Agent is saying me, give me my location, where I am, and the status of the room, and I'll return you the action. And these are the actions. So if the status is dirty, then suck the dirt. Else, if you are in, else means if the status is not dirty, that means if the status is clean, then the robot moves from, and the location is A, the robot moves to the right, that means to the other room. And if the location is B, the robot moves to the left, that means it comes back to A. Right? So this is a very simple vacuum cleaner agent that you have implemented in the form of a very simple function. Right? So what is this table on the top right corner doing? This table is primarily a sort of a lookup table, a very simple table which lists down all the precepts and the associated actions. And once you satisfy that, okay, one of these precepts are satisfied. So if you are in A and it's clean, you move to right. If you are in B and it's dirty, you suck the dirt. If you are in B and the room is clean, you go back to A. Okay, so all this can actually be performed by this very simple function that we have got. And how can you implement this very simple function? This very simple function can be implemented in any language. You can use Python or you can use any other language to implement this very simple vacuum cleaner program, right? right? Is there any question so far on this? So I hope Sanat, you are happy I'm using some slides finally. Is there any question about this? If there is any question about this vacuum cleaner agent, just let me know, because we may not have enough time to move on to the next example, but I'll try to very quickly go about that. But is there, if there is anything uh, I I couldn't understand, Sanat, what do you mean by this? Only this? Okay, that's good, Ahmed. Okay, so let's just okay, so this is just the introduction of AI. The first part, which I've explained on the whiteboard, I'll also share the slides for that. These slides would also be shared. And I'll also be sharing some handwritten notes. I'm not sure if you will be able to understand my handwriting or not, but anyway, I'll share those in the reference part. If you understand those, fine. If you don't, then you can use these slides. Okay, so you'll be getting these slides. Don't worry about that. And what I do on whiteboard, again, that would also be shared on the slides, right? Okay, so let's just talk about this, the last thing about the vacuum cleaner world. Okay, the and this is an important aspect that I think you need to understand. Okay, so if you have a vacuum cleaner robot, there are two rooms. The two rooms could be dirty. The two rooms could be clean. The two rooms could be, let's say, one of those rooms could be clean, the other could be dirty, right? So let's say there are 8 possibilities. Beyond these eight possibilities, there can't be other possibilities. Okay. So either it's state number one. State number one means that the robot is present in room A and both the rooms are dirty. That's state one. State two is that robot could be in room B and both of them are dirty. Both rooms are dirty. State three is that the robot is present in room A and only room A is dirty and room B is clean. So these are like different states. So you can see that there are 8 possible states, and beyond these eight possible states, you can't really have any other possibility, right? The only other possibility is that there are no rooms or there is no robot, right? But we are talking about this vacuum world problem where you have a robot, you have got these two rooms, and these are the different states in which the robot could be. The robot could start in any state, any of these states. So a single state thing, if you are absolutely clear, for example, if the robot is absolutely able to perceive the information and act upon that information, what would that mean? That would mean that the robot is in a position that it identifies out of these 8 states, it's present in which state. And that is what we call as a single state problem. Single state problem would mean that the robot is perfectly able to identify that it's present in state 1, 2, 3, 4, 5, 6, 7, or 8, any one of these states. right? So let's assume, and that's just an assumption, that the robot is present in state 5 and the robot is absolutely sure that it's state 5. Okay, so this is a single state situation. The next is what we call as, and of course, the solution is very simple. If you are very clear, if the robot is vacuum cleaner, robot is very clear, it's present in A and A is clean, it will move to B, right? So that's the solution that you can actually propose. What else is possible? Okay. Non-observable sensorless state. Now, what would that mean? That this is another possibility. Sensorless. The robot sensors start malfunctioning. The robot, the sensors are not working. So if the sensors are not working, what would be the perception? What would be the perception if the robots are not working? I mean, if the sensors are not working, sorry. Yeah. So if the sensors are not working, that means that it's not able to perceive. And that means that it's not able to identify out of these 8 possible states, the robot is in which state, right? Because it's a sensorless situation. It's a non-observable situation. The robot is not in a position to observe because the sensors are not working properly. They are not giving you the right information. The robot is not able to identify it's present in which state out of these 8. So the robot could be in any of these 8 states, but it's not able to identify, right? So what would be the solution in this particular scenario? What could be the solution? What would you suggest? I mean, if you are writing an agent function, and if you want to write a program that, let's suppose, if the robot is working perfectly and all of a sudden the sensors start malfunctioning, the sensors are not working anymore, how would you respond to that situation? How would you write your agent function in that situation? How would your agent function behave? Will you stop everything and you'll say that, okay, no, don't require any cleaning, just stop it? Okay. So, right, you are absolutely right. So you can think that all the rooms or both of the rooms are dirty, and you'll basically start cleaning both the rooms. But then there is one thing that is left that you will actually have to, okay. Okay. So the next thing would be that you'll actually assume, you'll also again assume that you are in any of these, you are in probably either in state 1 or state 2, right? Okay. So you could be in room A or you could be in room B. So you can assume any state. You can say that, okay, let's assume that I'm in A and both the rooms are dirty. And then you clean room A, move to the other room, clean room B, and come back to A if that's the resting position. The resting position is that you come back to A always after performing an action. So that's the sequence that you'll be getting if you are in state 1. If you are in state 2, you will clean room B, go to the room A, clean it, and stay there. So that means that you can start from state 1 or state 2, or you can assume any other state. You can assume any other state. But the problem with any other state would be that the rooms may not be completely clean. For example, if you assume that you are in state 5, right? So that means that you are assuming you are in state 5, but actually you are in state 1. That means that room A is actually not clean. You are only assuming that it's clean. Why you are assuming? Because your sensors are not working. Okay, so you might leave some of the rooms dirty. So that might be a problem with this type of a situation. So therefore, you will start from the worst scenario. The worst scenario is that you will assume everything is if both the rooms are dirty and you are either in A or in B room. Okay, and then you start performing the actions. Okay, and that's the non-observable or the sensorless state. So the start point could be any of these 8 states, but I would say that the safest of all would be there where you'll be actually completely cleaning both the rooms would be state 1 and state 2. Okay, the solution would be that you can actually start with state 1 or state 2 and then perform the actions accordingly. And then there is a third possibility where you have the partial observability, what you can say, option. Partial observability would mean that some of your sensors are working and some of the sensors are not working. Okay, you are absolutely right. I mean, Mohammed has actually pointed out a very good point that if the sensors are not working, then how would you move from one room to another room? Okay, so we said that the sensors are not working. It's not able to identify its position, but it doesn't mean that it's not able to move, right? So the actuators are still working. Okay, so this is you will actually implement that. Okay, if you are not getting any signal, if you are not, so this would be the program, the software that would control it. If you are not getting any signals from the robot, okay, but the actuators are working, then you will program it in a way that it will assume. Okay. Okay, so now the question is clear, which is saying Muhammad is actually saying that how would it detect that the room is clean or not? Now it will not detect that the room is clean or not. It will perform the suck operation anyway. Even if it is clean, it will perform the suck operation just to make sure that the room is clean, right? So that's why the detection part is not it becomes irrelevant in this case because the sensor is not like giving you any information at all, right? So this is the contingency plan. No, it because there are only 2 rooms there, so it will, if it is, let's say, in room 1, it will clean it, go to the room 2, clean it, and then stop, because you know that there are only 2 rooms, right? It will keep on doing it if it is not absolutely sure that okay, how many rooms are there. So if you have, if the software agent or if the program that you have written or the environment that you have got that contains only 2 rooms and only 2 actions are possible, right and left, it will perform right and left actions and perform the suck operation and stop. Okay, so the problem will come when you will have multiple actions, and then the selection of the actions would become a real problem. So instead of moving right and left only, you might move, let's say, up and down also, left and right also, or you can move, let's say, to n different number of rooms. Then the problem will start aggravating. As far as there is only 1 room and 2 rooms, then I think you can assume to be in a particular state and then perform the actions, right? So the only thing which I'm trying to suggest here is that if you are not able to perceive, then you assume some presumption or assume some perception and then you perform action. That's what it actually means so far, what we have discussed. I hope this is clear, Ahmed. Okay, wonderful. So partial observability would mean that okay, there are partly you are able to identify or perceive information, and this is about perception of information, not action. Partially you are able to perceive, partially you are not able to perceive. Now, one example for that could be that let's suppose you are unable to identify in which room you are, but you are able to identify whether there is dirt in the room or not. This is what partial observability would mean, or partial observable state would mean. Okay, or it could be the other way around. You may be able to identify that you are in room A or in room B, but the sensors that identify whether there is dirt in the room, they may not be there, or they may not be working properly. This is what we call as partial observability. Okay. Right. So if partial observability would mean, then again, out of these 8 possible states, if you are able to identify in which room you are, and let's say you have correctly identified that you are in room A, then 2, 4, and 5, these states will not be your starting states then. Okay, because in these states 2, 4, 6, and 8, the robot is shown in basically room B. Okay, so check the room and take decision which sensor work and which sensor is not working. Right. Okay. Yeah, that's possible. So whatever you are able to perceive, that sensor is working. The other one which you are not able to perceive, that sensor is not working. And then you have to come up with these contingency plans. Okay, now why we are discussing all these things? Because you have to plan for the worst scenario also. The worst scenario is non-observable states. You are unable to perform any action. Sorry, unable to perceive anything. The best would be that you are absolutely sure and you are 100% able to perceive, and something in between, which is called partial observable, where you are perceiving certain things and you are not perceiving other things. Right? I hope this is clear. So when you are writing your vacuum function, vacuum cleaner function, or your problem function or agent function, you should look for the best case, you should look for the worst case, and also look for some intermediate cases for which your program should be designed and written to handle these situations. Right? Is this making sense? Yeah, I'm waiting for your response. Is this making sense? Okay. So if I ask you to write down a small program for a vacuum world, would you be able to write down with this perception thing? How confident are you that you will be able to write down a program? I mean, we're not talking about the hardware yet. Of course, we'll not be having a real vacuum cleaner on which you'll actually be burning your program into, but maybe a sort of a vacuum cleaner world which we can create in a software or a simulation, and then you can test out various functions. So is it clear enough that you can actually write down a small vacuum cleaner agent for yourself using a simple lookup table? Okay, so I'm not getting any answers, so that means that you may not be that confident. I want you to be more confident about this. Yeah, that's wonderful. Ahmed, it's really good. I think it's not that difficult. Yeah, so you have already, I mean, I've already given you the function, and you just have to modify that function with more rules in it. Okay, if I show you, okay, let's say I've shown you this particular function here. This is just showing you one rule, right? So here you can actually write down multiple rules for your best case. So this is for the best case where you are able to perceive everything. But if you are not able to perceive, you might use another rule. Yeah, exactly. So if this sensor is not working, then use this rule. If this sensor is not working, then use this rule. So simple if else, if then statements. A very simple vacuum agent, right? And this is what we call as knowledge-based systems or rule-based systems. So the first rule-based system can very easily be developed, I think. Yeah, exactly. Ahmed, perfect. Great. I guess and this is a sort of a graph or a tree representation of different states, and this is how the states are actually connected together. It's self-explanatory. So, for example, if you start from, let's say, let's say if you start from this state, right? Then the possibility is that you might go to the other room without cleaning. That is what is this state is representing. The other possibility could be that you can actually clean this room, which is represented by this state, and then you can go to the other room, move left, come back. Okay, so this is a sort of a tree representation, and because you are like senior year students or fourth year students, and even more than that, so maybe you will be able, you know what a tree and what a graph representation is. So this is how these different states are connected together. And what you have to do is that you simply have to write down some rules which will take you from one state to another state. Every transition is represented by a rule. And this is what we call as a state space. Okay, we call it a state space. Okay, and this is what we call as a state space. Excellent. Jihad, you have actually already solved the problem. Wonderful. Excellent. So I guess I'll stop here, and I hope you enjoyed today's lecture. And if there is any feedback, just let me know. You can message me. We'll create a group, a WhatsApp group, and we'll post that link on that Moodle. And there you can become a part of it. I'll be available all the time. You can message me anytime, and we can. And I also have my YouTube channel. What I'll be doing is that I'll actually be sharing some of the recorded videos on that. At present, there are some videos present, but some of them may include Urdu language, which may be a little difficult for you guys. So I'll try to um, uh, convert them into English or with some subscripts with some subtitles in Arabic also. Um yeah, I'll provide you with the link, and also I'll also publish the grade breakdown on Moodle as well. So I'll definitely do that. But you need not to worry. I mean, relax. You shouldn't be worried about the grade. Uh, you'll be getting good grades, inshallah, all of you. Yeah, inshallah. So I hope we are left with the last couple of few minutes. If there is, I'll